depth first search and breadth first search? So what is a graph? You have done graph for Dijkstra, you have done graph for Floyd and all for finding the minimum distance from the graph. So what is a graph? A graph consists of vertices and nodes and edges. When you are calculating the time complexity or space complexity of graph, we always consider vertices and edges. So a graph basically consists of a set of vertex and edge. We can write a graph as V comma E. What is V? V is vertex, and what is E? E are the edges that are connecting those vertices. So graph traversal can be of two types. One is depth first search, another is breadth first search. Okay. Now how to do the
Yes, ma'am.
depth? You are writing, you are taking notes from this PDF. Are you all writing?
No,
If
ma'am.
you're not writing, at least take screenshot. Now, what is this bed first search? Here, what we do, we first visit this V1. After visiting V1, we find the adjacent vertex as V2. From V1, there are three edges, right? One edge is going to from V1 to V2. Another edge is going from V1 to V3. And the last one is going from V1 to V8. So, what are the adjacent vertices of V1? The adjacent vertices of V1 are V2, V3, and V8. Next, which one we will take? Next edge, next node, which one we will take? We will take as V2. From V2, we get how many vertex? V1. Also, we will get V4 and V5. Then if we consider V3, then we consider V4. Where is V4? V4 is here. So V4, from V4, how many vertex we will get? V2 and V8. Now what are the vertex from V3? Tell me, any one of you? What are the adjacent vertex of V3? No one.
Ma'am, V6 or V7?
হ্যাঁ, তো ওটাই তো জিজ্ঞেস করছো, তোমরা নিজেরাই বলো না কোন কোন ভার্টেক্স থেকে কিভাবে। ডেপথ ফার্স্ট সার্চ মানে it will go to the end, right? So how the vertices are searched? First we will visit V1. First we will visit V1. From V1 we will go to V2, V8 and V3. Then we will pick up V2. From V2 how many vertex we get? V1, because it is connected, it's the parent node, V1. Then we will get V4 and we will also get V5. Now V1 is already visited, we will pick V4. So for V4 we have V2 and V8, right? V2 is already visited, we have completed all kind of visit from V2. Now we will go adjacent vertex, which is V4, V5, V1, V6 and V7.
मैम प्लीज
V4 we
जूम कीजिए थोड़ा पीडीएफ को।
हाँ,
मैम पीडीएफ को जूम इन कीजिए थोड़ा।
जूम इन करेंगे तो ये ग्राफ ऊपर चला जा रहा है।
ओ
ग्राफ दिखा के समझाएंगे तो अच्छा रहेगा ना। So V4 and V1, these two are already visited. Now let us pick V5. Where is V5? V5 is here. What are the adjacent of V5? V5 adjacent is V2 and V8. These two, V2 and V8. These are adjacent of V5. V5 is here. So adjacent is V2 and V8. So we have visited both. Now we have unvisited graph as V6 and V7. Where is V6? V6 is somewhere here and V7 is somewhere here. So these two are unvisited. So how to do that? What are the vertex for V6? If we consider V6, we will get V8 and V3. These two, V8 is in down and V3 is above it. এরা কতক্ষণ ধরে ঢুকবে এখনো? So from V8 we get what? V6. Sorry, we have visited V1, V2, V4, V5. V5 we have visited. Now we have V6 and V7. These two are unvisited. In V6 we have V8 and V3. These two. And for V7, how many graphs are there? V3 and V8. These two vertex are left. So in this way, we are visiting all the vertex. Now at the adjacent vertex of V7, we have already visited all. So what is the final graph we get? V1, V2, V4, V8, then V5, V6, and V7. These are the graphs 1, 2, 1, V1, V2, V4, V8. We have traversed this part. Then we have another one which is V5, V3 and V7. V5, V3, V7. So in this way we have traversed the graph. So how the implementation? This is the small algorithm.
ম্যাম ওই V1 এর ক্ষেত্রে আমরা যখন V2 টা কনসিডার করছি তখন V4 থেকে যদি আমি সেকেন্ড টাইম আবার V2 যেতে পারি তাহলে সেটা কি আবার কনসিডার করতে হবে নাকি একবার হয়ে গেছে বলে আর আমি ওই
See, when we are considering only the visit from V2, can we visit V1? Yes, we can visit. Can we visit V4? Yes, we can visit. Can we visit V3? Sorry, এটা কত?
ওটা V5 ছিল।
V5. Can we visit V5? Yes, we can visit V5.
হ্যাঁ
বুঝলে? তাহলে
হুম,
এই পয়েন্ট থেকে আমি কোন কোন জায়গা ভিজিট করতে? How many nodes we can visit? We can visit all the nodes surrounding adjacent to this node. From V2 adjacent nodes we can visit. So we are only mentioning about this adjacent nodes. Okay.
ওকে ম্যাম।
A chotto algorithm. There is a small algorithm. Please write it for this. It's very small.
ম্যাম এটা একটু জুম করবেন?
Is it clear now?
Yes,
Yes, ma'am.
Hello, ma'am.
Yes, now you have to also know the time complexity. You have completed everything, right?
ম্যাম কোর্স তো অনেকক্ষণ থেকে জয়েন হওয়ার ট্রাই করছে, জয়েন হতে পারছে না।
হ্যাঁ?
কোর্স তো অনেকক্ষণ থেকে জয়েন হওয়ার ট্রাই করছে, বাট ও জয়েন হতে পারছে না।
ও আচ্ছা আচ্ছা। So now the next thing is the complexity of this graph. How to calculate the complexity of this graph. So for calculating the complexity, you have to know how much time each vertex is taking. So you have to calculate the complexity of this graph. So there are two parts. First, you have to mark the process, that is the edge part, and other is the vertex. So how to do that? We have a constant amount of time. We generally take a constant amount of time from traversing from one vertex to another vertex. Suppose we have taken, this is for just for your reference, like we basically take a constant amount of time for traversing from one vertex to another. So the total time of execution of a single vertex for this one vertex. So suppose for V1 is C1 plus C2 plus C3. What is C1? It is the constant amount of time. And what is the C2? It is for loop constant amount. What are the things we basically consider for calculation of a time complexity? Loop. We consider loop na for we consider loops for calculating time complexity, right?
Yes, ma'am.
We also consider what else thing? What else? If the loop is in a parallel condition or it is in a series, those things also we consider. Then also we have a constant amount of time which will be the up for execution, the maximum amount of time a particular code will take to run. That is that we consider as the upper bound. So C3 is that upper bound. So finally, what is the total time of execution of the loop? It is C1 plus C2 plus C3. Where big O, we are considering big O as the vertex and E is the edge. V is the vertex which is constant and edge is number of times from a particular. Hello,
Yes,
can
ma'am.
you hear? Okay. So from a so from a particular vertex, how many edges are there? That is a variable thing, right? That is a variable thing, but the constant is the amount of time taken to execute a particular vertex. So what is the time complexity? Is big O of E, V plus E. V means vertex and E. It depends on number of vertex. If this, suppose this graph has how many vertex? It has 8 vertex. So how many time it will take will depend on vertex as well as age. It can happen like you are working on a graph where there are less number of vertex. Suppose it has only 4 or 5 vertex. So definitely, like you have also seen for other graphs, it always depends on coverage. Now next comes the depth first, breadth first search. We have completed depth search, depth first search. We have completed. You
মডটা
have
কি
written
এখানে?
the.
হ্যালো ম্যাম।
হ্যাঁ
ম্যাম বলছি মডটা কি এখানে নিয়েছি মানে নেগেটিভ কেস যদি হয় তার জন্য?
হ্যাঁ মড ভ্যালু মানে কি এটা অ্যাবসলিউট ভ্যালুটাকে ওরা নিচ্ছে, অ্যাবসলিউট
আচ্ছা
ভ্যালুতেই মেইনলি ক্যালকুলেশনটা হয়। তাহলে
আচ্ছা,
আমরা ভার্টেক্স আর এজ নিয়েই করছি।
ওকে ম্যাম।
তো মানে এমনি ডিএফএস টা বোঝা গেছে, অ্যালগরিদম, এই গ্রাফ হাউ দ্য ট্রাভার্সিং ইজ হ্যাপেনিং, এটা লিখে নিয়েছো ট্রাভার্সিংটা? You have written this part. With this graph, you need to write this traversing part and the algorithm and the time complexity. Have you completed writing all this?
ম্যাম এই ট্র্যাভার্সিং এর পার্টটা একটু দেখান একবার।
Have you drawn this graph?
ম্যাম ওটা স্ক্রিনশট নেওয়া আছে।
নাও আছে, তাহলে এবার এটা একটা। Let me know once you are done.
मैम ये पीडीएफ प्लीज सेंड कर दीजिएगा।
হ্যাঁ ম্যাম হয়ে গেছে।
Done, completed.
ইয়েস ম্যাম।
Completed. Okay. Time complexity also we have written, right? Now we will go to the breadth first search. So how the traversing is happening? We have taken one vertex as V1. So what are the connecting? So what are the connecting vertex of V1? We will get V2, we will get V8, and we will get V3. So these three nodes are connected to V1. So first the graph will be, all these steps will be required in your examination. When you will write the answers, you have to show all these steps. So we have started with the parent node, that is V1. And from that V1, we are connecting to all the child nodes. What are the child nodes? V2, V3, and V8. So now let's consider V2. So from V2, you have two nodes. One is V4 and V5. See, from V2, you have V4 and V5. Finally, what you will get? So now from V3. So from V3, you get V6 and V7. Right? V6 and V7. So this is the entire search of in this way you are completing searching all the vertex V1, V2, V3, V4, V5, V6, V7, and V8. All the vertex are present here. Maybe they are not connected to each other. What you have seen in depth first, you have got a list of nodes. And here you get it, and for breadth first search, you get a graph which are not connected to each other, but still it's a complete with all the nodes. Right. Now just write about this algorithm and the traversal one.
ম্যাম ওই আগের কেসেও তো মানে আমরা যখন ডিএফএস করছিলাম ওটাতেও তো আমরা ওই মানে যেটা ইকুইভ্যালেন্ট নোড গুলো আছে মানে কাছাকাছি যে নোড গুলো আছে ওগুলোতেও আমরা সার্চ করছিলাম মানে
We are actually connecting the edges also, but we're not connecting all the nodes together.
মানে ওখানে আমরা একটা একটা করে জাস্ট সার্চ করে করে ওখানে ট্রাভার্স করছিলাম আর এখানে একসাথে সবকটা নোডকে কানেক্ট করে একেবারে এটা
ওখানে একটা নোডকে we were considering only one node, and then what we are doing is finding if all the ওখানে কি ছিল visit. The main important part of DFS was visit. We are visiting all the nodes.
হ্যাঁ
তাই না? ওখানে
আমরা কানেক্টেড গ্রাফ করছি।
হ্যাঁ ওখানে ছিল, আর এখানে ছিল এটা আলাদা। এটা হচ্ছে আমরা একটা একটা করে লেয়ার ওয়াইজ যাচ্ছি, ফার্স্ট সেকেন্ড থার্ড ব্রেথ ওয়াইজ we are going downwards. And
Okay.
there what we are doing, we are actually দেখো সেম লেয়ারেও কিন্তু we were doing the search. মানে সেম লেয়ারের পরেও কিন্তু আমাদের সার্চ হতো, maybe we have traversed the entire left hand side, then we went for traversing the right hand side, right? We have completed search from V1, V2, V4, V8, and then we went for V4, V3, and V7. We completed from here, and then we went for traversing the other side. But what we are doing for breadth first, we are considering V1, then we are considering V2 and V3. Like that, we are increasing. Means it's going sidewise. It's maintaining the level. Okay.
Yes.
Level wise.
Now write the algorithm.
আমি এটা ট্র্যাভার্সিং একটু দেখান।
ম্যাম একবার অ্যালগরিদমটা দেখান না।
ম্যাম এটা টাইম কমপ্লেক্সিটি কত ম্যাম?
আমি বলছি আচ্ছা, তোমরা কিছু ডিফারেন্স দেখছো ইন দ্য অ্যালগরিদম? Are you able to find any difference from DFS to BFS? See here we are using Q, and Q, what it does? First in, first out. Na? In Q we do na first in, first out. So what
Yes.
happens?
Yes ma'am, FIFO.
See the difference there, what you are doing in DFS, what you are doing, you're just using an array. You are just using an array. You are putting all the ordering. Suppose if we consider O by
Ma'am, your voice is not
we
coming.
can think like V1, V2, V3. See the difference here is for DFS, what we are doing, we are considering V1, then V2, then V4, then V8. We are considering a path actually for moving. Hello, can you hear me now? Hello? Hello? Can you hear?
Yes, ma'am.
What we are doing in DFS, we were actually following a path. Like we were moving from this V1, V2, V4, and V8. It's a path we were moving. We were not considering which node came first. Ideally, it should be like V1, then V2, then V3, then came V4, then came V5, then came V6, then came V7, then V8. But we were not considering it. We were only considering the path and we were dealing with it. But what happened for DFS is we are actually considering the hierarchy. First V1 came, so we will be considering that. Then V2 came, so we will be considering that. Then V3 came, we will be considering that. So we were following the hierarchy, how one after another nodes actually came. But in DFS, we were following the path. And that is why here we have taken mod e value as Rito Brotho, na? Rito Brotho said we are taking the mod value because in DFS we can also considering negative value for a edge. But what is happening for BFS? We are considering Q. Why? Because in Q, first in, first out. which node came before, that node will be processed before the next one. This is the difference between BFS and DFS. This is a major difference between BFS and DFS. Okay. Duto is same almost, but there are some cruise color preams. A small difference is there. Here we are considering the vertex. We are giving importance to the vertex, and there we were giving importance somehow to the edge. Clear now?
Yes, ma'am.
Good. So we have written this.
Yes, ma'am.
We have written the complexity also.
Yes, ma'am.
Queue operation. It's a queue operation. So the time required for just for the vertex, how many vertexes are there, and as well as scanning the edges, because one vertex can have multiple edges. So just for scanning the edges and for vertex, we were using this. Now a difference. Difference between prems and critical. Sorry, DFS and BFS. This is also important, okay?
Yes, ma'am. এটা আসবেই আসবে পরীক্ষায়।
হ্যাঁ,
এটা পরীক্ষায় এসে গেছে।
হতেই পারে, লিখে নাও ভালো করে। See, তিনটেই লিখবে, method, then DFS, then BFS. Data structure used, types of pages, you also have to write these points also.
হ্যাঁ ম্যাম, হয়ে গেছে।
Acha, then this comes. These are certain maths. You have to practice this also very well. Very important thing. One is adjacency matrix. I hope you know matrix. What is matrix? Like a 2D array. So here for representing a graph, how you will make this graph. So there are 5 vertex. We have written 1, 2, 3, 4, 5 here. These are 5 vertex. So from 1 vertex to 1, 1 to 1 is 0.
Nothing is there.
Nothing is there because we are in the starting point only. 1 if there is an edge, and 0 if there is no edge. So 1 to 1 is 0. See, diagonally it's becoming 0. Diagonally we have placed 0, right?
Yes, ma'am.
1 to 1, 0. 1 to 2, 1. 1 to 5, 1. 1 to 3, 1. But 1 to 4, no connecting. You remember in Dijkstra we were giving infinite sign when two edges, when
Yes, ma'am.
two vertices
Yes,
were
ma'am.
not connected.
We have to calculate all the distance.
মানে এজ যদি না থাকে তাহলে আমরা ইনফিনিটি লিখি। মানে
এখানে আমরা কি
এই ডিসটেন্স গুলো ক্যালকুলেট করতে হয়।
So here we are putting 0. So now next line. 2 to 1. 2 to 1, yes, there is a edge, so 1. 2 to 2, মানে 2 থেকে 2, it's 0.
Yes,
2
ma'am.
to 3, there is 1. 2 to 4, no connecting edge. So there will be 0. 2 to 5, no connecting edge. So again it will be 0. Then 3. From 3 to 1, yes, there is a connecting edge, 1. 3 to 2, yes, there is another connecting edge, 1. Now 3 to 3, nothing is there, so it will be again a 0. Then 3 to 4, yes, there is a connecting edge, so you are giving 1 over here. And from 3 to 5, 1 कर दीजिए तो 0 होगा. 3 to 5 will also be a 0.
Ma'am, your voice is not coming.
no, actually no connecting edge. Okay. Sometimes there can be a printing mistake. Now for here it is given 3 to 5 as 1, but 4 to 1 there is no connecting edge, 0. 4 to 2 no connecting, 0. 4 to 3, 4 to 3 there is a connecting edge, so it is 1. Now 4 to 5, yes, there is a connecting edge, 1, but 4 to 4 it is again 0. Now 5 to 1, yes, there is a connecting edge, 1, fine. 5 to 2, no connecting edge, so it's a 0. Now 5 to 3, there is no connecting edge. 5 to 3, there is no connecting edge, so it's a 0. Now 5 to 4, there is a connecting edge. 5 to 5, it's a 0. So this is the adjacent matrix. So from here, what they have done, this is for this graph, adjacency matrix. Now what they have done for this graph, there is another matrix. So you try to calculate this and show it to me. What will be the adjacency matrix for this graph? Anyone, try and show it to me.
ম্যাম এজের ক্ষেত্রে যদি ধরুন এজ ওটার মধ্যে যদি থাকেও দুটো নোডের মধ্যে, কিন্তু এজটা যদি অন্যদিকে মানে ধরুন এ থেকে বি এর দিকে যাওয়া যাচ্ছে, তাহলে আমি বি এর জন্য কনসিডার করব?
মানে B2 এ,
মানে 1 to 2 যাওয়া যাচ্ছে যখন, আমি 2 এর জন্য কি
বাট
তখন
2 এ হবে না তো, কারণ এটাতে তোর ডাইরেক্টেড গ্রাফ আছে না, একদিক থেকে যাওয়া যাবে।
ম্যাম হয়ে গেছে।
হয়ে গেছে ম্যাম।
Whatever you were discussing, it was correct because it's a directed graph. So it can go from 1 to 2, but it cannot go from 2 to 1. Okay.
ইয়েস ম্যাম।
It's a directed graph. Keep this in mind. Done, everyone? Anyone show your answer sheet?
Yes, ma'am. Done.
So show your answer sheet. মানে ঠিক বুঝতে পারছি না তোমারটা।
ম্যাম কিন্তু ম্যাম সবকিছুই ঠিক আছে ম্যাম, যা করেছি এটা বলতে পারি।
তুমি এরকমই করেছো তো?
হ্যাঁ হ্যাঁ, সেম একদম।
Anyone else? Anyone else?
ম্যাম করেছি ম্যাম, মিলেছে।
মিলেছে?
হ্যাঁ ম্যাম এটাই আছে।
Very good. I mean, if this kind of question comes, you can do like if I give this kind of graph and you have to explain, you can do by this way, right?
ম্যাম এটার কি এক্সপ্লেন করতে হবে পরে, মানে আমরা কোথা থেকে কোথায়
No,
নোটগুলো?
no explanation. Even if anyone asks you, then you can explain like 1 to 1 it's 0, 1
হ্যাঁ
to 2 it's 2, 1 to
মানে ম্যাম টেবিলটা ক্রিয়েট করলেই হয়ে যাবে, তাই তো?
huh?
ম্যাম
টেবিলটা
ডাইরেক্ট
ক্রিয়েট
One
করলেই হয়ে যাবে।
ক্রিয়েট করলেই হয়ে যাবে, তাই তো? কোনো
হ্যাঁ,
এক্সপ্লেনেশনের দরকার আছে ট্রাভার্স করতে হবে যে?
1 to 4 it's 1. আচ্ছা বাকিগুলো সব 0. Then comes 2. 2 to 1 it is a directed graph, so we cannot move. 2 to 2 থেকে 2 it's 0. 2 to 3 it's 0. It's not connected. 2 is the child node here, so it is not connected to anyone. So everything will be 0 over here. Now for 3, 3 is again a child node, but 3 is connected to 5. So only for 5 you have 1, others it's 0. Next comes 4. 4 is only connected to 6. So for 4 you have only one connection, that is in 6. Then comes 5. For 5 you have two connections. One is for 4, another is for 7. So for 4 and 7 you have made connection. Then for 6, 6 does not have any connection to anyone, so it's 0 everyone. And for 7, you have only one connection, that is up to 6. Clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So if somebody gives you this question like V1, V2, V3, V4, V5, V6, from here if we ask you like if you can make the graph, can you make it? See, from V1 it is connected to V2. From V2 it is connected to V3. V1 also connected to V3. Then you have V4. V4 is connected to V3. V4 is connected to V5 and V5 is also connected to V4. Now you have from V4 to V6 and V4 to V1. This is the final one. Okay. This is actually the graph which shows
ম্যাম আমরা ডাইরেক্টেড ডিরেকশনটা কি করে বুঝবো ম্যাম?
ওটাই দেখানোর জন্য চেষ্টা করছি ওই গ্রাফটাকে এটাকে পাশাপাশি রেখে see from V1 you can go to V2 only and nowhere else and V3 okay so from V1 you can go to V2 and V3 see the very first line from V1 you are going to V2 and V3 right from V2 also you can go to V3 from V2 you can go to V3 from V3 you can go to V4 from V3 you can go to V4 okay from V4 you can go to V1 from V4 you can go to V1 from V4 you can also go to V5 and V6 so you can go from V4 to V1 and V5 and V6 fine now from V5 to V4 how V5 to V4 you have gone from V4 to V5 and also from V5 to V4 see from V5 to V4 and finally you have V6 V6 is not connected to anyone only V4 from
ম্যাম বলছি কি এই গ্রাফটা কি ম্যাম কোশ্চেনে দেওয়া থাকবে?
তোমাকে যদি এরকম একটা গ্রাফ দিয়ে থাকে
হ্যাঁ তাহলে তো ইজিলি ম্যাম এটাকে করতে পারবো।
না তুমি এই গ্রাফ থেকে তো করতে পারবে মানে এইটা থেকে তো গ্রাফ করতে পারবে নাকি
হ্যাঁ হ্যাঁ এটা পারবো।
ম্যাম ওই ইয়েটা মানে যদি V1 টু V6 আমরা যদি ওই লিস্ট মতো দেওয়া থাকে তাহলে সেখান
না
থেকে আমরা ডাইরেকশন
ওটা তো দিলে হবে কি করে? ওটা দিলে বুঝতে পারবো না কি করে?
দেওয়া থাকবে?
এটা থেকে বোঝা যাবে না ভেরি
হ্যাঁ
ডিফিকাল্ট দ্যাটস
হ্যাঁ
the graph you didn't reply but how will you do where are the connections you won't be able to understand anything these are just a list of vertex you can at least
yes হ্যাঁ হ্যাঁ how many vertex are there in the graph?
list of vertex but where are the connections connection is actually here from here you can make the graph you cannot make a graph from this list it's impossible you can say a number of vertex 6 present but from this one only you can say like what are the connections see from here only you can say from v1 v2 v3 they are all connected v2 and v3 is connected v3 v4 is connected v4 and from here also you can say like v6 is the child node and v3 is a child node
ম্যাম গ্রাফ থেকে কানেকশনও তো বের করতে দিতে পারে।
got it see v6 don't have any connection to anyone v4 is also there v6 is also there v5 is also there everything is mentioned here all the connections are given here okay now
Yes,
what
ma'am.
is a connected graph and a disconnected graph what are connected these are connected graph 1 2 3 4 all the points all the vertices are connected to each other this is a connected graph this is also a connected graph 1 2 3 4 5 6 7 these are again a connected graph but is G3 a connected graph no because there is no connection between 2 to 3 there is no connection between 2 to 3 you cannot go from one vertex to another easily connected graph কি যে গ্রাফে কোনো জিরো থাকবে না apart from when zero suppose one is connected to one there you get put a zero but other than that if you are trying to form
And
that
basically, connected graph is a type of complete graph, right?
এমন একটা গ্রাফ আছে যেখানে সবকটা ভার্টেক্স থেকে সব ভার্টেক্সে যেতে পারো সবকটা ভার্টেক্সে 1 থাকবে অ্যাপার্ট ফ্রম কোন ভার্টেক্স মানে 1 থেকে 1 কি হবে 0 2 থেকে 2 কি হবে 0 3 থেকে 3 কি হবে 0 4 থেকে 4 apart from that all the matrix entire matrix will consist of one value understood all the vertex will consist of one value but only own vertex will have 0 as their value. Here also, you see, this is also a connected graph, G2. From 1, you can go to 2 and 3. From 2, you can go to 1, 4, 5. From 5, you can go to 2. And from 5, you can go to, from 4, you can go to 2. You can travel up to 6. Up to 7, you can travel. From 7, you can go to 3. You can go to 1. You can go to 2. You can go to 5. You can travel the entire thing. So, this is a proper binary graph. It's a balanced binary graph. So that is a connected graph. But what about this one? 1, 2, 4, and 7. This is not a connected one. 5, 6, 7, 8. Again, this is not a connected one. So these two are not connected. Okay.
Yes, ma'am.
So just take a screenshot of this, like which are connected and which are not connected. At least you can show it by diagram, like this is the connected graph and this is a not connected graph. Done.
হ্যাঁ ম্যাম হয়ে গেছে।
Okay, what is a tree is a connected acyclic graph. Now, what is acyclic? Means there is no cycle present. And what is a cycle? See, here it is showing a cycle. 1, 2, 3, 4, again back to 1. So it's a cycle. 3, 4, 5. This is a cycle. But what is a acyclic graph which will have no cycles in them? This kind of connection will not be present. And what is a directed graph? A directed graph is basically for every pair of distinct vertex U and V, there is a directed path from U to V and from V to U. U to V and V to U means from 1 to 4 you can travel as well as from 4 to 1 you can travel. So this is a connected graph. This is a strongly connected graph. Okay, this is a strongly connected graph. What is a biconnected? Take a screenshot of this page. Done. So these are some of the graphs. I will send you some notes for it. Biconnected, construction of biconnected graph.
ম্যাম এই পিডিএফটা এখানে সেন্ড করে দেবেন
না এগুলো হয়ে গেছে See, difference between BFS and DFS. You can answer, right?
Yes, ma'am.
Explain properties of BFS. That also you can write. Explain game tree. Okay, write these 3 questions. This is your homework.
ম্যাম ওই বাই কানেক্টেড গ্রাফটা একটু দেখান না।
Biconnected graph. Biconnected. all the vertex have at least two connections. See, from A you can go to E and you can go to B. From B you can go to A and you can go to C. From C you can go to B and you can go to D. From D you can go to E and you can go to C. From E you can go to A and you can go to D. So all the vertex has two connections to itself. All the vertex are connected to another vertex. There
Means
are
the
always
degree is 2.
two adjacent connections with it. Huh?
ম্যাম ইচ মানে প্রত্যেকটা ভার্টেক্সে ম্যাম ডিগ্রি ম্যাম 2 থাকা থাকে।
দুটোই করে থাকবে। It has will always have two adjacency, two adjacent vertex with it. So this is a bi-connected. And what is a uni-connected? All the vertex have what? One adjacent vertex. A has got E, E has got D, D has got E. So all the vertex has got one only connection. So that is a undirected what? Uni connection. And this is bi-connection.
ম্যাম এটা কি ম্যাক্সিমাম এক্সাম্পলের ক্ষেত্রে পসিবল যে আমরা যদি বাই কানেক্টেড থেকে একটা ভার্টেক্স যদি মানে সরিয়ে দিই, এলিমিনেট করে দিলে তাহলে আমাদের ওটা ইউনি কানেক্টেড হয়ে যাবে?
Almost. After
ম্যাম your voice is not coming.
So that is an unconnected, undirected graph. And have you written these three questions? These are your homework. Take your homework, write fast. Anyone has the syllabus with you now? Anyone has got syllabus with you? Can you please tell me what are topics are left for your syllabus? Prem Ranjan, you have your syllabus?
Yes, ma'am.
So what are the topics remaining?
Just wait, I will check.
টপিক গুলো কি কেউ বলতে পারবে? এনিওয়ান?
ম্যাম আমাদের ব্যাক ট্র্যাকিংটা হয়নি।
Huh?
Backtracking.
Can you show it? Ula, can you show it?
Ma'am,
What a
can I,
topic.
ma'am, can I
Yes,
share?
মানে নি মানে। Yes.
আমি ফোন দিয়ে দিচ্ছি ল্যাপটপে জানাচ্ছি তো ম্যাম প্রবলেম হবে। মডিউল 4 এন্ড 5 টা ম্যাম শুধু বাকি আছে আর 3 লাস্টের একটু বাকি আছে।
4 আর 5, 4 আর 5 এর টপিক গুলো কি? Can you send it? না চার্টে পাঠাও।
ম্যাম ওই একজন স্ট্রিং ম্যাচিং প্রবলেমটাই আর কে স্যার করিয়েছিলেন একটুখানি।
Can you send here in the message chat one? Oh, dynamic programming and string matching problem. These two are left, right? Hey, dynamic programming, how?
না ম্যাম ডাইনামিক প্রোগ্রামিং নোশন এন্ড এলপি
4 and 5 left, right?
4 and 5 আর 3
4 and 5.
লাস্টের কিছু বাকি আছে।
3 is completed.
ম্যাম ব্যাকট্র্যাকিং হয়েছে।
Huh?
ব্যাকট্র্যাকিংটা
3 is completed. Only 4 and 5 left. Right. String matching problem and notion of NP completeness. Okay. Rest we have completed. Fine. Okay. Give your attendance now.
ম্যাম বলছি ব্যাক ট্র্যাকিং এ আপনি যে নোটসটা লিখিয়েছিলেন ওটার উপরেই কোশ্চেন আসবে নাকি মানে এমনি
হ্যাঁ।
অ্যাপ্লিকেশন টাইপের কিছু আসতে পারে?
অ্যাপ্লিকেশন টাইপেরই মানে যেরকম বলেছিলাম ওরকম।
আচ্ছা।
তোমাদের ক্লাসে যা পড়ানো হয় তার থেকেই কোয়েশ্চেন আসে, তার থেকে বাইরে খুব একটা আসে না। হোমওয়ার্কটা যেটা দিলাম হোমওয়ার্ক করো। 61, 62, 63.
Present, ma'am.
I'm present 63.
I'm 61.
हाँ ठीक है। 61 present, 63 present, 64, 65.
Yes, ma'am.
Were you present yesterday also? 65,
Yes, ma'am.
66, 67, 68,
Yes, ma'am.
69, 70, 71,
Yes, ma'am. 71.
72, 73, 74,
Ma'am, 74 present. 74 present.
75, 76,
76 present, ma'am.
77, 78, 79, 80.
Present, ma'am.
81.
Present, ma'am. 81.
Ma'am.
Uh,
Ma'am, 73.
81.
Ma'am, 70.
Ma'am, 81 present.
हाँ, 82,
Present, ma'am. 82.
Ma'am, 70.
83,
Present, ma'am. 83.
84,
Yes, ma'am.
85, 86, 87, 88, 89,
Yes, ma'am.
90,
Yes.
91, 92, 93, 94,
Present, ma'am.
95,
Yes, ma'am.
96,
Ma'am, 96 present.
96,
Yes, ma'am.
Ma'am, 95 present.
97,
Present.
98,
Present, ma'am.
Ma'am, 97 present.
Ma'am, 98 present.
98,
Yes, ma'am, present.
99, 100,
Present, ma'am.
101,
Present, ma'am. 101.
102,
Yes, ma'am.
103,
Yes, ma'am.
105,